Hello, I'm going to talk about this trig equation exercise, which is going to involve solving equations that look like this. And we'll note already numbers like this, 1/3, are not going to involve common familiar angles like 30 degrees or 45 degrees. So we're going to have to figure out what to do about that. And then using inverse trig functions to write the solutions as indicated. So we'll jump in and we want to write solutions in 0 to 2 pi. So 1/3, if I think about our unit circle, this is going to be up at 1. So 1/3's about here. So I'm looking for an angle right there. Now I can rewrite this trig equation using inverse trig functions as x is equal to sine inverse of 1/3. And that indeed will be my first solution right over there. Now there's going to be a second solution I can see from the intersection of that line, and I do think about how to describe that. And that could be a little bit tricky. So why don't I back up from this problem and solve a different problem? Here, I'm going to be changing this problem to 1/2, because all of a sudden that is a very familiar one. Let's see, at 1/2, sine inverse of 1/2 is equal to pi6. And similarly, on the other side, I have 5 pi6 because sine of 5 pi6 is equal to 1/2. So I have my two angles, pi6 and 5 pi6. And notice that they are both the same distance from the x-axis. So I've got pi6 angle over here and the pi6 angle over here, of course, going in the opposite direction. Okay. Similarly, if I had, we'll say if this is 30 degrees, okay, and this is 150 degrees, I could get 150 degrees by taking 180, subtracting 30, and there I go, 150. So let's apply this to my previous example. So to get this angle in here, I'm going to start at pi and then subtract this little angle here, which is the same as that one over there. So I'm going to subtract sine inverse of 1/3. And these are my two answers. Okay. If I want to describe them over the real numbers, well, they're not equally spaced. So I'm going to start here, and then I would go all the way around to hit it again. So the easiest thing to do is to describe it as sine inverse of 1/3. That's my first angle. And then I'm going to write k times 2 pi. So the 2 pi stands for going around the circle, and then number k stands for the number of times I go around the circle. We also could just say that k is an integer. Okay, because the integers stand for, -1, -2, -3. That'd be going around the circle backwards, or 0, 1, 2, 3. Those are the number of times going around the circle in a forward direction. And then we also add in sine inverse of, oops. I'm just copying it from up here. So pi minus sine inverse of 1/3 plus k times 2 pi. And there we go. We have found all the answers to the equation from 0 to 2 pi and over all the real numbers. Let's move on to the next part. So we have sine of x equals -1/3. The only thing that's changed is that our positive has gone to negative, but we can still draw a similar picture. Okay, we have an angle down here. Recall the range of sine inverse is from -pi/2 to pi/2. And so this angle is going to be sine inverse of -1/3. But it's going to be between -pi/2 and 0. And I want it to be from 0 to 2 pi. So I am going to need to take, let's see, I've gone my negative angle. I'm going to need to add an entire 2 pi to it to get it to be inside the interval from 0 to 2 pi. Okay. My angle, my other angle is going to be down here. And here I can think this through. It's going to have the same amount as from here. So if I were to go to pi, that would get me halfway around the circle. And then I want to go this amount. Well, sine inverse of -1/3, that's a negative amount. So if I subtract it, it'll be like adding the positive or the absolute value. So minus sine inverse of -1/3. Maybe a different way of thinking about it will be, if I were to use angles, say I'm here at -20 degrees, and I want to come over here to find the corresponding one over here. Well, that would be 180 degrees. It's going this way, and then subtract the -20 degrees. So that would get me to 200 degrees. Did the same thing over here. It just looks more abstract because of the way it's been written, with that pi and the minus sine inverse of -1/3. Okay. And then when we describe things over the real numbers, in this case, it is all about just adding multiples of 2 pi. So I have x is equal to sine inverse -1/3 plus k times 2 pi. And x is equal to pi minus sine inverse -1/3 plus k times 2 pi. And it's always good, since this is a different problem, I will just state again, k is an integer. And that's that. We can describe solutions to equations in an abstract kind of way using our inverse trig functions. Now you may try some problems with cosine and with tangent, and each of them is each of the problems will have its nuances. But if you use pictures to figure out where the angles are and then reason through, and also maybe go into simple examples, you'll have the skills to figure them out.